The slightest oversight on your part can cause serious problems. One thing which computers taught me was that small things can have big ramifications. As I thought about the hollow earth idea, it became apparent to me that the slightest oversight by scientists could have a radical effect upon their ideas about the inner earth. Many books have been written about the hollow earth, and the vast majority of them are rubbish. I realized that nobody had applied serious thought to the subject since Marshall Gardner. IT often borrows on ideas and concepts used by engineers. One of these concepts is a feasibility study. I decided to do my own feasibility study on the hollow planet idea to see if it had any merits. My approach was the following. I knew there were many uncomfortable scientific facts which did not fit current theories properly. I wondered if some of these facts could be related to the hollow earth theory. So I set out to find all the facts I could which did not fit current theories, and to see which, if any, could be tied back to the hollow earth theory. I wanted to see if the hollow earth theory could explain some things better than the solid earth theory. The father of the hollow earth theory is none other than Sir Edmund Halley. He was one of the greatest astronomers and scientists of his time. He discovered Halley's comet. He was the first man to propose that the earth might be hollow. He studied the motion of the earth's magnetic field. In those days, they did not know much about magnetism. He suggested that maybe there were some magnetized objects moving around inside the earth, which were causing the earth's magnetic field to move. He came up with the theory of concentric spheres. He imagined there were several spheres inside the earth, and each of these was magnetized. He thought they were rotating at different speeds, thereby causing the earth's magnetic field to move. When there was a great aurora in England, he suggested that it was caused by a luminous atmosphere which was inside the earth and which was leaking out. He suggested that there was a great hole in the Arctic that led into the interior of the earth. The hollow earth theory has survived for centuries, egged on by odd people. It is said that Leonhard Euler, the greatest mathematician of all time, also became interested in the idea. He supposedly did not think the idea of several spheres was practical. So he simplified it into a single shell with a large cavity inside it. Euler was a prolific writer, and most of his texts are in Russia. A great deal of his writings have never been translated into English. Sadly, I could not find any of his writings on the hollow earth, even though there are rumors that he played a major role in the development of the idea. Many works of fiction have been written about the hollow earth. The most famous of them is Journey to the Center of the Earth by Jules Verne. Scientists are convinced planets cannot be hollow. This is because of the theory of gravity. In astronomy, the masses of all the planets are relative. So astronomers will tell you that planets are not hollow because when they compare the mass of one planet to another, they find them to have a pretty similar density. Because scientists are convinced the Earth itself is hollow, because scientists are convinced the Earth is solid, they then reach the conclusion that all the planets must be solid. However, if the Earth were hollow, then it would follow that all the planets are hollow. That is an important realization which I came to, that either all the planets are solid or all are hollow. If some were solid and others were hollow, then astronomers would have noticed this a long time ago. You might wonder how come they are convinced the Earth is solid. This comes from the Cavendish balance experiment. The Cavendish balance is a device that measures the attraction between two lead balls. Scientists then take these results and extrapolate them to find the mass of the Earth. This gives them a mass of 6.6 trillion tons. Take note that this is the one and only method we have of estimating the Earth's mass. There is no method of cross-checking these results. The problem with the Cavendish balance experiment is that it is based on a number of assumptions. The lead balls, for example, are electrically neutral. If there is any difference between the planets and those lead balls, then the results of the experiment will be meaningless. For example, the Earth contains electrical currents inside of it up to 1 billion amps. If electricity were to affect the way gravity works, then it would nullify the results of the Cavendish balance experiment. Consider too that in nature, static electricity has an attractive force which is incredibly strong compared to gravity. It is assumed that planets are electrically neutral and that static electricity is not a factor to be considered. If any of these assumptions are invalid, then the Cavendish experiment is worthless. In my book, I discuss a great many issues relating to gravity, which we will not go into now. But gravity is not as cut and dried as you may think. There are a great many technical issues to do with gravity that have yet to be solved. Dr. Tom Van Flandern, a professional astronomer in the USA, pointed out that even such things as the speed of gravity are unknown. There is no atomic level theory of gravity which works. We have hardly advanced our knowledge of gravity since Newton's time. One thing I discovered in my feasibility study was that a scientist in the 1960s, Dr. Saxel, mentioned he had a discussion with Albert Einstein. Einstein told him he was convinced that electricity and gravity are interrelated. Dr. Saxel went on to do a number of experiments with electrically charged pendulums to see if Einstein's ideas were correct. He got some very strange results with his electrical pendulums. Nowadays, scientists deny the possibility that electricity may affect gravity. However, if it does, then their estimates of the mass of the Earth will be completely wrong. We know there are electrical currents inside the Earth. Calculations based on the Earth's magnetic field show that deep inside the Earth there must be electrical currents of up to 1 billion amps. If these currents affect gravity, then the Earth may weigh much more or much less than the Cavendish balance experiment shows. I now want to focus on seismology. I have done something that nobody has ever done before. I dug into the science of seismology to see if it could provide clues as to whether planets could be hollow. What I am about to show you is something which I wish someone would put on a documentary or on a TV program. I feel it is important for people to see this. Let me explain the principles on which seismology is based. Firstly, seismic waves are the main means we have of knowing what lies inside the Earth. Earthquakes generate seismic waves. These waves travel throughout the Earth. The only place we can measure these waves is here on the surface of the Earth. We have instruments which measure the various vertical and horizontal movements of these waves. Seismology is based on the mathematical interpretation of seismic waves. Scientists first create various solid Earth models of what might be inside the Earth, and then they use this to interpret their seismic results. Scientists never consider the possibility that the Earth might be hollow.